The Earth rotates at roughly 1,670 kilometers per hour at the equator. Everything on the surface moves with it, including you, the atmosphere, and the oceans. Newton's first law of inertia states that an object in motion will continue moving at the same speed and in the same direction unless acted upon by an outside force. If the Earth were to stop instantly for 5 seconds, the ground would cease movement. However, because of inertia, everything on the surface would continue moving at 1,670 kilometers per hour. The atmosphere is not physically bolted to the Earth. It rotates along with the planet due to gravity and drag. If the planet were to stop instantly, the atmosphere would retain its momentum, continuing to move at over 1,600 kilometers per hour. This creates supersonic winds exceeding Mach 1.4, effectively scouring the surface and leveling all infrastructure. The result is a global windstorm that strips the surface of everything not anchored to the bedrock. Oceans are not just sitting on the surface. Like the atmosphere, they possess massive momentum from Earth's rotation. If Earth stopped for 5 seconds, inertia would force the water to keep moving forward at the original velocity. This results in massive, high-velocity tsunamis, surging hundreds of miles inland and scouring coastlines clean. Stopping the Earth's rotation abruptly creates an immense, immediate problem. The planet is a massive spinning sphere, and its crust must carry that momentum. Stopping this spin generates extreme torque. This force isn't just felt on the surface, it ripples deep through the mantle and into the crust. The Earth's crust is composed of massive tectonic plates. When rotation halts, these plates don't stop together. They experience sudden, massive lateral stress. This stress is enough to trigger simultaneous global earthquakes, each exceeding magnitude 8.0. It is a planetary-scale structural failure. The result is a total reordering of the surface, as the crust buckles under the impossible demand of instantaneous deceleration. Rotational speed is not uniform across the planet. Because Earth is a sphere, the speed of rotation varies depending on your latitude. At the equator, the Earth moves at 1,670 kilometers per hour. As you move toward the poles, this velocity drops to 0. This creates a dramatic difference in inertial force. A sudden stop would eject everything at the equator with massive kinetic energy. At the equator, destruction is total. At higher latitudes, the force is significantly reduced, though still devastating. The core takeaway: the closer you are to the equator, the more catastrophic the sudden change in momentum becomes. After 5 seconds of stillness, the Earth resumes its rotation. This restart isn't a gentle transition. It's a catastrophic snap back to momentum. The sudden acceleration acts like a massive whip crack. As the surface snaps back to speed, the inertia causes a violent secondary shockwave. This pulse further pulverizes remaining structures, turning the surface into a field of high-velocity debris. Even if the planet survives the stop, the restart completes the destruction. You might wonder, could Earth actually stop spinning for 5 seconds? The answer is a definitive no. It is geophysically impossible. To stop Earth, we would need to overcome its massive angular momentum. Any external force capable of applying this braking effect would provide enough kinetic energy to vaporize the entire planet, effectively ending the experiment before it even finished. The internal structure of Earth, our mantle, liquid outer core, and solid inner core, functions within a stable equilibrium. A sudden halt is purely a thought experiment, a tool for us to understand inertia and scale, not a geological event that can ever happen. Our journey through this hypothetical scenario reveals a vital truth. The danger isn't merely the stopping of the Earth. It is the violent change in velocity, or deceleration, that would shatter the structure of our world. This scenario highlights a fundamental principle of physics: inertia. Even our massive planet follows the rules of motion. The resistance of an object to changes in its rotational state is defined by its moment of inertia. Our atmosphere, oceans, and life itself are held in a delicate, precise balance by the stable, constant rotation of our planet. This thought experiment serves as a reminder of how inertia governs every frame of reference we experience. Physics reveals the unseen rules that keep our world steady, allowing us to thrive on a planet in constant motion. Keep exploring the laws that shape our universe.